Question 6 from 2303. It says a Boeing 737 aircraft is moving at 70 meters per second. When it first touches down, the aircraft immediately uses its reverse thrusters to slow down the acceleration A in meters per second until the aircraft reaches the normal taxiing speed of 6 meters per second is given by negative 3.2. How many seconds after touching down does the aircraft take to reach normal taxiing speed? So the aircraft is taxiing, it's going on. So let's see what we can come up with here. So the first thing is we're given acceleration. So let's start there. So acceleration, and I'm going to let's take the exercise here before I begin. So it's going to be exercise 23.03, put in question 6, and it says acceleration is, so I'll put everything we know down first of all. So the initial speed it's moving is 70 meters per second. So it lands and it touches down here, and so at t equals, well, let's call that t equals 0, yes? T equals 0, that's when it touches down. V is equal to 70, yeah? What else do we know? The acceleration is negative 3.2, and then all these are in meters per second or meters per second squared. And we want to find out how long it takes to reach the point over here. We don't know what time that is, but we want to find that time, because it says how long does it take to reach. So how many seconds? T equals question mark, but we do know that V has got to go from 70 all the way down to V equals 6 meters per second, yeah? That's what we need, that's what we know. So let's go, so we're going from here to here, and we're decelerating at this rate. So let's then, well, we've got an equation for acceleration. Let's find an equation for velocity. And once we do that, we're in a better position, yeah? So let's go ahead and do that. So velocity is equal to the integral of acceleration with respect to time. So I can just rewrite that as the integral of negative 3.2 with respect to time. So velocity, therefore, is equal to negative 3.2, and we're going to increase time dimension by a factor of 1 power. So here it is, divided by 1 to the power of 1. And of course, we're going to add c to the end of it. So what do we know? Well, we know that when t equals 0, that velocity equals 70. So I could actually just put that into here right now. I could say, so here's velocity, negative 3.2 t plus c. We know that velocity is equal to 70, which is negative 3.2, times 0, when t is 0. So I'll put here when t equals 0, yeah, plus c. So of course this equals 0. So that means c must equal 70. So now I know what my c value is. C is 70, and I can go ahead and plonk that straight into the equation. So v, therefore, is equal to negative 3.2 t plus 70. And there is my equation for velocity. Now, we're told we want to find when, in other words, the time when velocity is 6. So I can go ahead now and make v equals to 6, and then we're going to solve for t. So 6 is equal to negative 3.2 t plus 70. So I'm going to, first of all, subtract 70 from both sides. Subtract 70, there we go. So 6 minus 70 is going to be 64. So I've got negative 3.2 t is equal to negative 64. Of course, I've got negatives divided by negatives, which is kind of cool. So I'm going to negative 3.2 divided by negative 3.2. So t is going to, well, if this was 32 into 60, it would be 2, but it's negative 3.2, it's 10 times bigger, so it's not going to be 2, it's going to be 20, and time is in seconds, and that would be my answer.